Alright, so today we're going to learn how to factor cubics, and then we're going to apply that, the factoring of cubics and factoring of quartics in solving and finding those zeros. So, let's start with the first one. If you go into your book and you're in section 5-3, you're going to find out that there is an actual formula for this. There's two formulas. You have to memorize one if there's a minus sign in the middle, or there's a formula to memorize if there's a plus in the middle. And feel free, if you want to go that route and memorize it, you go ahead. I'm going to show you the same thing but written out differently for these problems. So the first thing you need to know is that we're going to take, and we're looking at this x cubed here, the first term, so we're going to take the cube root of that first term. So going up here, if I take the cube root of x cubed, I get x. I'm going to keep the sign the same, so I'm going to write same sign here. And then I'm going to take the cube root of the last term, of the last part. So I'm going to take the cube root of 8, and the cube root of 8 is 2. Now, to get the second parenthesis here, to get the rest of it, I'm going to ignore what's up there in black, and I'm going to just look at that first parenthesis that I just created, and I'm going to see that I'm going to look at that first term, and I'm going to square it. So you're going to square the first term, meaning I'm going to take this x right here, and I'm going to square it, so that becomes x squared. The next part is I'm going to multiply the two things inside that parenthesis together, and I'm going to change the sign. So we're going to change the sign. And then we're going to multiply the two terms together. So in the case up here, I have an x and I have it technically a negative 2. So that becomes a negative 2x, but I must change the sign, so it becomes a plus 2x. Last but not least, we're going to square the last term. Now if I square the last term, whether I'm squaring a negative number or a positive number, my end sign will always be positive. So I'm going to square the last term. Okay, so when I take this negative 2 here, this negative 2 right here, and I square it, I'm going to get a plus 4. And that's it. So let's apply that same information to the next problem, the one down here. I look at 64 and I look at 125, and I say, is there a greatest common factor that I can factor out? Can I GCF? No, I can't. So then I go, is 64 and is 125, are they perfect cubes? And the answer is yes. So if the numbers, when I'm looking at two-term cubics, two-term binomial cubics, we're looking at binomial cubics, I ask myself, can I take the cube root? And if I can, then I'm going to do this process. So the cube root of 64 is 4. The cube root of a cubed is a. Keep the sign the same. The cube root of 125 is 5. Close off the parenthesis. Open my new parenthesis. I'm going to square the first term, which is 4a. So when I square 4a, I get 16a squared. When I multiply the two terms in here together, that's 20a, and I have to change the sign, so it's going to be a minus 20a. And then I'm going to take this last term here, and I'm going to square it, and I'm going to get 25. And that's the end of that one. Now up here on this last example up here, I see that I have an 8 and I have a 64. And I know that I can GCF, greatest common factor is 8. I can take an 8 out of both of them. So I take the 8 out. So 64 is 8. And then I recognize the fact that this is a perfect cube and the 8 is a perfect cube, so I get m plus 2, cube root, square it, multiply the two together, change the sign, square the last. And so that would be my answer for this, for factoring. All right, on the next page, we're talking about solving polynomials now. And so the first thing you need to do is factor. Well, as you remember from all the factoring we've done so far, you can't factor unless this says equals 0. So I'm going to subtract 4 from both sides. That now equals 0. And I'm going to factor this. If, ladies and gentlemen, your exponent here, your highest degree, that exponent, is even, it will factor just like all the quadratics we did back last semester. Now, not all of them factor, just like not all quadratics factor, but you will attempt to factor it into two binomials. So x to the 4th breaks up into an x squared and an x squared. The factors of 4 that when I subtract give me 3 as a middle term are 4 and 1. Being that this is a negative 3, my 4 must be negative, my 1 must be positive. Now, I have quadratics here, so I have a degree 2. I need to try to factor these again into two binomials, if possible. So this first one here, what are the factors of 4 that when I subtract give me 0 as a middle term? Well, that's x minus 2 and x plus 2. Once again, I recognize this as a perfect square problem because this I can square root evenly and this I can square root evenly. Now, the next one looks like it's going to factor the same way because both of them are perfect squares, but because of the plus, I cannot factor it like I did the last one. That plus, there are no factors of 1 that when I add them together give me 0 as a middle term. So this just gets written down as is. Now I set each of my factors equal to 0, and I solve them. Now this one here you're going to recognize from yesterday because when I get x squared equals negative 1. I can take the square root of both sides like we did yesterday to get x by itself, but this becomes plus or minus the square root of negative 1. Well, from last semester we know we can't have a negative 1 as under the radical, so this really becomes x equals plus or minus I, because if you remember the definition of I, our imaginary number, is the square root of negative 1. So this right here, these are the actual zeros of the function, and this is the imaginary piece. So if you were using a graphing calculator, which most of you don't have at home, but if you did, this guy looks kind of like this. Not exactly, but kind of. If you notice, it only crosses the x-axis 2 times, not the 4 that you're used to. So once again, this is an exception to our end behavior rule. We got the same end behavior, we just didn't get the same number of zeros crossing the x-axis. All right, let's look at example number 2. This is going to be x cubed minus 1 because we have to bring that 1 over. And we're going to factor it like we just did the last slide. So we took this cube root and we take the cube root again. And then we square the first, multiply 2 together and change the sign, and we square the last. Now, 99.9% of the time, when you do a perfect cube problem, this piece here is not going to factor. You're going to have to use the quadratic formula on it. So, this is going to be x minus 1 equals 0, so x equals 1. This piece over here, though, on the other hand, is going to be x squared plus x plus 1 equals 0. And I need to recognize that a is 1, and b is 1, and c is 1, and plug that into the quadratic formula. So, going this way, that's going to become x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is negative 1 plus or minus the square root of 1 minus 4 over 2, which equals negative 1 plus or minus the square root of negative 3 over 2. Can't have a negative under the radical, so this is negative 1 plus or minus I square root of 3 over 2. So this guy over here is my only zero of the function. Those are my imaginary answers. If you were to put this in a graphing calculator and graph it, this graph looks something like this. So we have the same end behaviors of down and up, but we only cross the x-axis 1 time. So ladies and gentlemen, those are your notes for today. So if we go back, your homework is the 2 left columns in the section 10 through 24 and the 2 left columns in the section 39 to 50. So you're not doing the right column in either one of those sections. I hope you have a good weekend, and I will see you back here on Monday.